This video is on the objective: perform and interpret a hypothesis test for dependent or paired data in two dependent samples. And this is with technology, specifically the calculator. I'm going to be using the TI-84 Plus on the computer if you have a TI-83 or 84. And you click on the More instruction. It takes you pretty well through how to do these problems. So this time because I've done the stuff with the calculator a lot before, I know this is a different kind of test, but I'm just going to do the one video on this. Because if you see me do it once, I'm going to be doing it that same way, maybe with a different alternative hypothesis. But I'm going to be doing it basically that same way every time. So yeah, click on More Instruction, look at what they have to offer you, their videos, notes, their examples, and hopefully those help you out. Alright. So here, Camden is a professional disc golf player contemplating if he should switch to a new line of discs that are supposed to be more accurate and reduce the variance in the disc's flight path. He obtained a set of the discs from the new line and paired each new disc with a similar type of disc in his existing set. Camden then set up 12 targets that would be appropriate for each type of disc thrown, threw the pair of discs, and measured how far each disc landed from the target. The data is given below, with the distance from the target in meters. Assume that the conditions required for this hypothesis test are satisfied. Alright, so we're going to use a calculator to test the paired data, right? Because, first pair of discs, again, each disc from these sets are comparable discs. Alright. So this is like first kind of disc, second kind of disc from these, third kind of disc, all the way up to the 12th one, and their distances from the 12 targets. So we're going to use a calculator to test the paired data, where alpha is 0.1, right? Alpha is 10%. For each disk type, compute the difference D using the distance the new discs were from the target minus the distance the existing disc, his current set was from the target. Which of the following statements are accurate for this hypothesis test in order to evaluate the claim? Alright, so here's the claim: that the true mean difference between the distance from the target to the new line of discs and the distance from the target to the existing line of discs is less than 0. Alright, so I'm going to write that claim out. Alright, so I got the calculator pulled up now. The claim is that the true mean difference in those distances, right? So that mu sub d is less than 0. Right? They're telling us this. So if this is less than 0 and my differences were new minus existing, like his existing set, if this is true, right, this statement means, if these differences on average are less than 0, that means the existing distances are larger, right, and the new distances are smaller. So that means the new ones are better, right? The new ones get me closer to the target than the existing ones. So the new ones are better, is what this is saying. Right, they get me closer, they get them closer to these targets. Well, then once a claim is established, right, you set up your hypotheses: null hypothesis, alternative. Now this would be the alternative, right, because it doesn't involve equality. And then the null hypothesis would be the opposite of that. But what you're going to be assuming is the equality part. All right, this will be our null hypothesis. Assume that there is no difference on average between these two sets of disks. Right? They're on average the same. same quality. And this one, is saying that the new ones are better. Now, the way the alternate hypothesis looks tells me that this is a left-tailed test. All right, so I'm going to keep that in mind when I go to the calculator later. And the value of alpha, right, they told us the significance level was 0.10, 10%. Right? I'll keep all this in mind when I go back to the thing, and we'll enter stuff on a calculator. So I'm going to pull the calculator up here. And I'm going to enter these lists of data, right? The distance from the targets for these new disks and the distance from the target for these existing disks, right? So I'll call those list L1 and L2, right? You go stat, edit, and then down L1 here, I'm going to put the distance from the targets for those new disks, 3.5, what is it, feet? Yeah, something like that. 3.5 meters, 3.5 feet, I forget, probably early in the problem. 1.6, 1.9, and I'll come back. I'm going to come back when all of these are entered. So again, down L1, the new disk distances from the targets, and then down L2, the existing disks. All right. So you see I've entered now the 12. Now you can't see all 12 because I'm down the list, but I've entered all 12 of those new disk distances from the targets, and then down L2 the 12 existing disks distances from the targets. And what we do with all these paired data, anytime we're in a scenario where we have these paired data sets or dependent samples, I'm going to go to list L3 here and make a list of the differences between these L1 values and L2 values. Now they told us to take the new minus existing, right? So in L3 I'm going to have the values be the L1 values, right? The new distances minus the L2 values, the existing. Alright, so you see L3 here. Now this is the one I'm going to focus on, this list. This is the list of all the differences. Alright. So get out of here. And now I'm going to go and perform a t-test. Right? Remember the distribution of the d bars, right? The averages for these, these differences, these sample differences, was a t distribution with, in this case, it would be 11 degrees of freedom, right? Because there are 12 pairs here. There'd be 12 differences. And this is no different than the t-test we did when we had one mean. I hit stat, go over to tests, and then t-test. Because again, I know there's two samples. I get it. There's two, but these two number 3 and number 4, these were for when you had two independent samples. When you have two dependent samples like these, two paired samples, you're changing it, you're transforming them into one sample of differences. So when you perform a test about the mean of the differences, you're doing just a one sample t-test, or just the t-test, number 2. And then am I given data or statistics? Now they didn't give me any means here, they just give me a these lists of data. So I'm going to stick to the data thing. Alright. And then what's mu0? Well, mu0 is the mu d from the null hypothesis. Right? So what's mu d assumed to be? It's assumed to be 0. So let's keep that as 0. Now this list, the list of data, this is the list of differences, which in my calculator was L3. Right? When I did L1 minus L2, put them in L3. That's the list of differences. Each one of those values in L3 is only counted once, right? There's no frequency list. And then below that, how does the alternative hypothesis look? It is a left-tailed test. That mu d is less than 0. So I move this over to this middle one here. The first one would be a two-tailed test. This is a left-tailed test. The third one would be a right-tailed test. And then I just go calculate. And look, they show you what the alternative hypothesis is. They give me a test statistic, right? The t-score, negative 1.489, whatever. They give you the d-bar, the average of those sample differences. They give you the SD, the standard deviation of the sample differences. They give you the size of the sample, 12. But the most important line is the p-value. And the p-value here is this p line is 0.082. All right. And then what do? Remember, you compare the p-value to alpha. Now the p-value is only 8%. Alpha is 10%. The p-value is less than or equal to, but less than alpha in this case. If that happens, right, remember, if the p-value is less than or equal to alpha, you're going to reject the null hypothesis. So this statement here, rejecting it. All right. What I assumed that there was no difference between these disks. I'm rejecting that statement, meaning we're going to take the other one. We're going to accept the alternative. The alternative was the claim that the new ones were better. The new ones had a better, got me closer to the targets than the old ones, than the existing ones. So we're keeping this. So the final conclusion would be that, there is enough evidence, right? There is evidence to support the claim. Right? There is evidence, or is sufficient evidence, enough evidence to support the claim, right? That the new ones are better. So I'd end up saying the new ones were better, and this one got me closer to my targets, and then I would probably then switch over to buying them. All right. So back here, after punching them in the calculator, doing that t-test with that list of differences, we're going to reject. Now it's one. You select all that apply. One of the first two. So remember, I reject the null hypothesis, and then which one is the proper conclusion. This one says, based on the results of the hypothesis test, there is enough evidence at the 10% significance level to suggest that the true mean difference of the distance to the target, to the new line of disks, and the distance from the target to the existing line of disks is less than 0. And yes, that was the claim, and saying there is enough evidence to support the claim, and that's exactly what I was saying earlier. If we are rejecting the null hypothesis, that means we're leaning toward the alternative, which was the claim, and saying that we support the claim. There's enough evidence to support that claim, suggest that claim. Wonderful. All right, so again, this is the only one I'm going to do for this. Just remember that if you got this paired data scenario, you need to make a list of the differences between those sets of data, and then go to the t-test, right? Just a one sample t-test, and the list you're using is that list of differences. And you got to pay attention to, do you have a left-tailed test, right-tailed test, two-tailed test, right? And that's all. After you enter all that stuff, it'll give you the p-value. And then you just compare the p-value to alpha, decide whether or not to reject the null hypothesis, and then state your conclusion. Right, so I'm hoping that watching me do this one time here, maybe looking at the more instruction, reading the answer explanations when they come up, hoping all this stuff helps you when you work on this material on your own. And thanks for watching.